Alright, my friends, welcome to 5-4 video point slope form. After this lesson, I'll be able to write and graph linear equations using point slope form. Last video talked about slope intercept form. Now this video is going to talk about point slope form, still for linear functions. Here we go. Stop, make sure you're listening as well as watching. Do a good job. Alright, here we go. The red line shows the altitude of a hot air balloon during its linear descent. What is an equation of the line in slope intercept form? Hint. What is the altitude of the balloon when it starts its descent at x equals 0? Well, a couple important things here. It says it's a linear descent. So that means the slope or the growth rate is consistent. What is the equation in slope intercept form? So I'm going to need to figure out the slope, and I'm going to need to figure out the y-intercept. All right, here we go. This comes off of last video. The slope-intercept form is useful for modeling real-life situations when you're given a starting value, which would be the y-intercept, and a rate of change, the slope. Remember that the problem said that the descent is linear, so the slope is constant. Therefore, the change between any 2 points would be the same. So we can pick any 2 points to find the slope. So I'm looking for the m and the b because that's what my slope-intercept form is. So as I look at the picture, I'm going to pick these 2 points here in the middle. Doesn't matter which 2 you pick. So from here to here, remember it's vertical change over horizontal change, or change in y's over change in x's, or rise over run, however you want to think about it. So it's going to go down 40 over 20. Well, negative 40 over 20 is still the same as negative 2. Right, so there's your slope. If you're doing slope-intercept form, well, now all you need is the intercept. So remember, your starting point, your y-intercept, is where your line hits the y-axis. So if you look at the graph, right there is where your graph hits the y-axis. So I just got to figure out what that number is. So if you look here closely, 600, a line, and then 640. So each line is 20. 620, 640. This line here would be 660, so it looks like it hits between 640 and 660. Let's call it 650. So that would be the starting point. So very simply, the the slope-intercept form would be y equals negative 2x plus 650. There's your slope. There's your y-intercept. All right, great. So we just talked about, and all last lesson was about learning how to write the equation by using its y-intercept. This video talks about how to write it without using the y-intercept. So if they give you the y-intercept, just do slope-intercept form. If they don't, well then you'll use this form, which is called point-slope form. We can use the slope of the line at any point on the line to write and graph an equation of the line. Any 2 equations for the same line are equivalent. So because you may be picking a different point on the line than your neighbor, your equations may look different. However, if they are correct, they will still be equivalent. All right, so here we go. The point-slope form of an equation of a non-vertical line with a slope of m, slope is m, and through the point x1, y1 is, here's your formula, y minus y1 equals m times x minus x1. Okay, that's point-slope form. All right, so what do all those symbols mean? Well, m is the slope. All right, and then the point that you pick has 2 coordinates. It has an x-coordinate and a y-coordinate. Those numbers for that coordinate would be x1 and y1 in the formula. Okay? So this is a cool note. It says when you use y minus y1 equals m times x minus x1, x1 and y1, these points, represent specific points. So they'll be filled in with numbers. The x and the y, without the subscript, those are variables. So they will stay there because they represent any point. So my final answer will have x's and y's in it. Okay? And those x's and y's would be this x and this y. So when I do point-slope form, there'll be a number for m, a number for x1, a number for y1, an x, and then a y. Okay? All right, here we go. A couple things we got to do. So a line passes through negative 3, 6, has a slope of negative 5. So they gave me a point and they gave me a slope. Well, let's use point-slope form. So if x1, there's your point, is negative 3, y1 is 6, and your slope is -5. So I have all the info I need. All I got to do is fill it into that template. So there's my template again, and I'm just going to fill the numbers in where they go. Now, you have to be a little careful here because your formula or your template involves minuses. So when you have a minus and a negative value, like minus -3, you would turn that into a +3. Okay, so this is a little formula that causes a little bit of trouble just because it has minuses in it. So when I have a minus negative, that would turn into a positive. All right, so this would be the equation in point slope form. Awesome. All right, here's another example. So the point is 8, -4. The slope is 2/3. So 8, -4, slope 2/3. There's your template, and now we're just going to put them in where they go. Well, x1 is here, y1 is there, and the slope is 2/3. So I have minus -4 because y1 was -4, and the formula has a minus in it. So there's that, and this is because y1 is -4. X minus, and now x1 is just 8. So it just says x minus 8. I'll just clean it up a little bit because minus negative we would turn into positive, and then we can just get rid of that parenthesis there because we don't need it, so we want to get rid of that. So I got y plus 4 equals 2/3 x minus 8. All right, these parentheses here are important, so please make sure you have those. All right, problem 2 asks me to graph it. So they're giving me the equation in point slope form, and I just have to graph it. So I need to figure out the point, and then I'll use the slope to find the next point, and then I'll draw the line. All right, so that's the slope, 2/3. Here's your x1, your x coordinate, and there's your y1, your y coordinate. So you have an x1 of 2 and a y1 of 1. Again, be careful. This is not -2. It might look like -2, but since the formula is x minus x1, what you see here is what you get. All right? If it was supposed to be -2, it would say x plus 2, because you'd have x minus -2. We'll look at that one next. But I got a point, 2, 1. So how do I graph 2, 1? Well, start at 0, over 2, up 1, bang, there's your point. All right, now use your slope. Remember, slope, vertical change, horizontal change, rise over run. So from this point, up 2 over 3. Up 2 over 3, 2 points, that's enough for a line. Bang, there's your line. Looks like that. Okay? Great. Here's another example. So now I got y plus 3 equals 4/5 x plus 6. All right? So really, you could rewrite that as y minus -3, 4/5 x minus -6, because your formula has minuses in it. So in order to put this in this form, you would need this to be x minus -3, just like here. All right? Now it's easy to see what the point is. There's your slope, and then your x-coordinate would be -6, and your y-coordinate will be -3. So you have x1 at -6, y1 at -3, and a slope of 4/5. So your first dot would be at -6, -3. Always start back here. 1, 2, 3, 4, 5, 6, down 1, 2, 3. -6, -3, there he is. From there, go 4 over 5. Rise over run. Up 4 over 5. Bang, there he is. I can just draw the line, and it looks like that. All right? Great. Now, problem 3. They want me to use 2 points to write the equation, and they want me to write it in point slope form. Okay? All right. So the first thing I better do is figure out the slope. So slope, remember, vertical change or horizontal change. I got slope formula, or I could just count because it's a graph, so it's easy to count. So I would just count up 7 vertically over 3. Up 7 over 3 is just 7 over 3. All right? And now I can pick either point to use for my x1 and my y1. I usually try to pick positive numbers, so I don't have to worry about that whole minus negative thing. So since I get to pick, I'm going to pick things that make my life easy. It wouldn't be wrong if you picked the other point. Those would still be equivalent equations. Your neighbors would look different than yours if you picked a different point, but it will still be the correct answer. All right, so x1, I picked this point. So x1 is 1, and then y1 is 4, and the slope is 7 over 3. Okay, so as long as I have those numbers, all I got to do is jam them into the template. Well, that's pretty simple. So x minus, well, x1 was 1, 7/3, y minus, well, y1 was 4. So there it is. There's your slope. There's your x-coordinate. There's your y-coordinate. All right, great. Same question, but now they're giving me 2 points. And here are the 2 points that they gave me right up here. All right, so the first thing I better do is find the slope. Because I already have a point. I actually have 2. I can pick one. But I need the slope. So remember, slope, when you don't have a picture, when you don't have a graph, you need slope formula. Subtract the y's on the top. Subtract the x's on the bottom. Remember, all this is trying to do is let you know that if you use this y first on the top, you got to use this partner first on the bottom. You can use this y first on the top. You just got to use this partner first on the bottom. All right? So again, I like to kind of list everything out to keep myself organized. There's x1. There's y1. There's x2. There's y2. Bang. And then just jam them into the formula. All right, remember, a lot of these problems you get some minus negatives, so just be careful. 2 minus -1 over 1 minus -3. Well, that would just give me 3 over 4 because minus negative turns into positive, so it's 3 over 4. So now my list of information would look like that. All right. If I'm you, I probably just add this part to my list. Okay. It was easier for me to just make the whole thing again so it was all right together. Okay, so now what do I know? Well, I know the m, and I can pick either point for x1, y1, for the point. So it doesn't matter. Even though this says x2 and y2, it's still a point that's on the line. And in fact, that's probably the one I would pick because I like dealing with positive numbers so I don't have to deal with that whole minus negative thing. All right? So then I just jam them into the formula, the template, y minus y1 equals m times x minus x1. There's your m, there's your y, there's your x, there's your y. Okay? So it should look like that. So I know your formula says x1 and y1. Well, you could use this one, sure. But you could also use this point. So I'm going to use that point because it's a little easier with those positive numbers. All right, there's your slope. There's your x-coordinate. There's your y-coordinate. All right, awesome. Here's another example. So 2, 4, and then -3, -6. Well, the first thing I better do is find the slope. So I just list everything out. Slope, subtract the x's on the top. I'm sorry, the y's on the top, the x's on the bottom. -10 over -5 is positive 2. Negative divided by negative, positive 2. So now I have all my info, including a slope of 2. Pick either point you want. In this case, I would select the 2, 4. All right? But you could select the -3 and -6 one if you wanted. You just can't mix them. You can't take this x, but then that y. All right? And that makes sense. So, once you know your info, just plug them in. There you go. Y minus y1 equals m times x minus x1. All right? Good to go. So if you pick this as x1 and y1 here, all right, you could still use the -3, -6 in here for your coordinates of your point. You certainly could. All right, great. So there's your slope, there's your x-coordinate, there's your y-coordinate. All right, last thing. Table shows the altitude of a hot air balloon during its linear descent. What equation in slope-intercept form gives the balloon's altitude at any time? What do the slope and the y-intercept represent? Okay, so they're asking me for some slopes and y-intercepts, but they're not giving me the y-intercept in the table. So what I'm going to do is use point slope form, and then that'll lead me into slope-intercept form. So there's some info from the table. I just picked these first 2 rows. Doesn't matter. It told me it was linear, so it doesn't matter which 2 points I pick. I could use the 10 and the 70 and the 640 and the 490 if I wanted. It doesn't matter. So there's my points. If I'm looking for the slope, I just subtract my y's, subtract my x's. All right. And I would have negative 50 over 20, all right, which would be negative 2.5. Normally, I tell you not to, turn it into a decimal, but in a practical example kind of problem like this, it probably makes more sense to talk in terms of a decimal than it does into a fraction. Okay? So now I have a slope. I have a bunch of points that I could pick from. So I'm just going to pick one of the points and I'm going to use it in point slope form. I have a point and a slope. So use point slope form. I'm going to use that first one, 10, 6, 40. All right, you could pick any of these points that are on this chart. All right, as long as you use the x with his y partner, it doesn't matter. So I'm just going to take that and plug it in. There's my x1, there's my y1, there's my slope. All right, so that's good to go. There's your slope, there's your x-coordinate, there's your y-coordinate, bang. But they asked me for slope-intercept. They want to know what the slope and the y-intercept represent. So if I can take this and turn it into y equals mx plus b, that would be good. And that's actually not hard to do because all it is distributing this negative 2.5 and then moving everything so that the y is all by himself on the left. So all I have to do is get rid of this minus 640. So I would add 640 to both sides. And I would just wind up with y equals negative 2.5x plus 665. Now notice this is in y equals mx plus b form. So there's your slope, negative 2.5. There's your y-intercept, 665. So remember what those numbers mean in terms of the problem. The balloon starts at 665. There's your y-intercept, your starting point, and descends, goes down because it's negative. It's going down at a rate of 2.5 feet per second. Because remember, your slope is change in y, m, meters, over seconds. All right, so it really should be a rate of 2.5 meters per second. Okay, so just make sure you fix that. All right, I'll see you next time, y'all. Peace.